All right, so here we are at the end of gas laws. This is when we go back to late last November when we were doing train tracks, early December, and we combine it with what we know about gas laws. Because I taught you how to do mole to mole questions using train tracks, right? I give you mole, you find the exchange rate from the balanced equation, then you give me back the mole of another country. I even taught you how to go grams to grams. Grams of one country to grams of another country. What I did not teach you is how to go grams to liters or liters to grams. Why? Because you needed to know about the ideal gas law. So these kinds of questions will marry train tracks plus the ideal gas law. Sometimes you may have to do the ideal gas law plus train tracks. Thanks to the ideal gas law, we can expand our love for stoichiometry. Stoichiometry is just a fancy word meaning you're going to have to use train tracks. From mass to mass problems to problems involving gases. All right, this is the question. Whenever you see a balanced equation, you need to think to yourself, oh crap. And now you can begin whining all you want. It won't make a difference if you're taking a test, because you'll still need to be quiet. If you see a balanced equation, odds are this is going to be a longer question that you may want to answer. And when you're taking the next test, which is 80-question multiple choice standardized test, when you're taking the EOC, you may want to look at the balanced equation and go, okay, I can do this, but I'd rather attack the ones that are faster and then come back and do the ones that are long train tracks. Okay? Here we go. Calculate the volume of a gas produced at 1 atmosphere and 25 degrees C. So far I'm thinking, hey, I need the ideal gas law. By the complete decomposition of 10.5 grams. So they want the volume of gas. If they give me 10.5 grams, oh, this is a train track question. So I begin with 10.5 grams of KClO3. I do not want it to be in KClO3. I need it to be in oxygen. So I'm going to have to travel to that land. First place I go to is the bank, where I will exchange grams for what? International monetary unit. And the bank will always issue me how many moles for how many grams? 1 mole for the formula mass. Potassium is 39.1, chlorine is 35.5, and 3 oxygens is 48. Somebody add that up real quick. What? Okay, so now we are in terms of mole. Now we can travel. We can travel from KClO3 land to oxygen land. And where do we get that exchange rate?
Equation.
In oxygen, it'll cost me 3 moles, what typically will cost me 2 moles in KClO3 land. Now, if you've gotten it that far, stop. Don't write anymore, because this next step is going to be wrong. But you tell me why this next step is going to be wrong. So I go to the bank and I tell the teller, okay, I would like to exchange all my moles for liters. And they'll say, don't you mean grams? They go, no, I need it in liters. They go, okay. So for every one of your moles, I will give you 22.4 liters. But that cannot happen, because it's not at STP. Good job, Noah. It is at SP, standard pressure, but it is not at standard temperature, which is 0. So I cannot use our magic number 22.4 now. That's it. I'm stuck. I am stuck at this point. Can I convert to N, to moles? Yes. 10.5 divided by 122.6, enter, times 3, enter, divided by 2, enter. You need to go? Yes, go. Okay, so we're stuck. I need liters. But all I got was moles. What can I possibly do? Okay, I only use one gas law, and that one gas law is?
Combined ideal gas law. Same thing.
I need volume. Do I know pressure?
Yeah.
Do I know temperature?
Yeah.
Do I know the number of moles?
Yes.
I have two R's. Can I use one of the two?
What's the R? Rate.
0.0821 atmospheres, liters per mole Kelvin, and 8.31 kilopascals, liters per mole Kelvin. So, it's on the back of a periodic table. V is equal to nRT over P. Number of moles. Can we use an R? Which R? Do we know T?
Yeah. Wait, why aren't we using the kilopascals? It's in bowls.
Do you see why?
Oh.
All divided by what is it? So, this is a marriage of train tracks and the ideal gas law, where I'm given everything I need to find moles, and then I use moles with the ideal gas law to find volume. Would have been really nice if it had been at STP, wouldn't it?
Yeah.
But it wasn't. Any questions? Now, what if I give you the volume at non-standard conditions and I ask you to convert to grams? You have to go backwards. So you use ideal gas law first and then train tracks. All right, here's the next question. Okay, it is at STP, but better than that, what do you not have? What is missing that makes you happy? A balanced equation. Okay, so this one is going to be an easier one. So it involves gases. What equation do I always write down?
Ideal gas law.
Do I know the volume?
Yeah.
Do I know the temperature?
Yeah.
Standard. Do I know pressure?
Yeah.
Standard. Okay, that will allow me to find the number of moles, but they don't want the number of moles, they want the number of molecules. But if I find the number of moles, can I find the number of molecules? What is standard pressure?
180.
Standard volume. No, not standard volume. They gave us the volume. Which R should we use? And the temperature is? 1 times 1.75 divided by 0.0821, enter. Divided by 273, enter. I don't think so. What is it? Can I get that confirmed? Okay, so now how do we convert moles to molecules?
Number of moles times 10, or molecules times 10, or ions.
Moles. Molecules. So 0.0788 times Avogadro's number. Any questions? Yes?
Why could we not use the 22.4 method?
Because you did not have 6.02 times 10 to the 23rd. I knew that I did not have 6.02 times 10 to the 23rd because I had 1.75 liters. If they had given me 22.4 liters, then I would have said, oh, I don't even have to work this out. It is Avogadro's number. But it was going to be just a tiny fraction of Avogadro's number because I didn't have 22.4. Now, Maxine, this is what you're expecting. First of all, what do you see that makes you go, oh? All right, sorry. Calculate the volume of CO2 at.
Standard temperature, pressure.
Okay, so now what can we use that we were not allowed to use with the first equation? 22.4. Here we go. 152 grams of calcium carbonate. We go to the bank. We say, hey, we would like to exchange calcium carbonate for moles. The bank always says, okay, for 1 mole we'll give you. Okay, you're going to have to figure that one out. Then I go to the exchange rate to see how much it's going to cost me to live in carbon dioxide land. And that exchange rate is
1:1.
I got 100.1. Yeah,
all right, now I'm in moles of carbon dioxide, so I go to the bank and go, hey, because we're at STP, can we exchange it right here, or do I have to use the ideal gas law building? We can exchange it right here because, and the bank says, oh yeah, honey, for 1 mole, I will give you
22.5.
I got 34.014.
yeah, because this is a little bit more than 1. So yeah, what is it, 30? Do you see the difference between this one and the first one? The first one, we were stuck having to use the ideal gas law. The second one, we could use 22.4 because it was at...
STP.
All right. Let me give you the balanced equation. You figure out which way you have to do this one. Go. Figure out which way you have to do it. The hard way or the easy way, and then do it. Yes, I'm sorry, it's 26.5 grams of zinc. Hmm.
It's the hard way.
How do you get hydrogen? No, I know, but
It's 0.405.
how do you know what to get from hydrogen?
Calculator.
Just remember,
What?
when you're doing like the train track, how do you know to get hydrogen?
The goal is hydrogen land. All right, what's the number of moles?
0.405.
Now we use that in conjunction with the ideal gas law to find liters.
How do you know the weight?
Is that right? 64.7?
No. I did it right. I put it in my calculator.
All right. Any questions? Now remember that in your homework, there will be times in which I ask you to go in reverse. So what the first thing you'll have to do is use PV equals nRT to find moles. And then go moles to moles, moles to grams. So it's this only in reverse order. All right. So I've shown you how to do mole to mole, mole to gram, gram to mole. Those are all old train track questions. And now I've shown you how to do gram to liter if it's not at STP. I even showed you how to do grams to liter if it is at STP. Now, what if it's liter to liter? Liter to liter is actually very, very easy type question if the conditions don't change. If the conditions don't change, if they're both at STP, or if they're both at the same temperature and pressure, you do them the same way. Here's 350 milliliters. I don't like, when dealing with gas laws, I don't like milliliters. But it's really easy to convert to liters. Move the decimal place 3 places over. Of hydrogen gas. They want to know how many liters of water vapor. So, I make a train track. I need to get rid of liters of hydrogen gas. What is the one unit that everyone accepts? So I go to the bank and I ask them, okay, I have this many liters. What will be the exchange rate to moles? And the lady goes, all right, it depends on whether the country you're in has the same temperature and pressure. Yes, it's the same temperature and pressure. Because in this case, standard temperature and pressure means same temperature and pressure. So she goes, oh, okay, if that's the case, then I will give you 1 mole for every... Nope, this is liters. 22.4 liters. Okay? So now I'm in terms of moles of hydrogen. Can I now do the travel? Can I travel now?
Yeah.
Moles of water. Where do I get that ratio from? 2 to 2. So in order to go back and convert it back to liters, I have to go back to the bank. And she'll ask me the question, are you guys in the same temperature and pressure?
Yeah.
And if the answer is yes, then she will give me 22.4 liters for every 1 mole that I have. Look at this question. What's so weird about it? Right? Those are the complete inverse of each other.
So
Will they ever not be the complete No, they will always be the complete inverse of each other. Because you have to use 22.4 liters to convert to moles, and you have to use 22.4 liters to convert back to liters. So really, what's the only important step in this train track? That's because you've seen how this ratio is moles, right? 2 moles of this, 1 mole of this, makes 2 moles of this. Well, as long as gases are at the same temperature and pressure, then that means that they can also give you the liter ratio. The liter ratio. Yes?
So, since they're both 2, doesn't it stay?
Yes, yes. In this case,
In that case, but in
right.
other times it'll have
If we were converting to oxygen, then it would be 2 liters of hydrogen will react with 1 liter of oxygen.
Okay.
We don't have to do the 22.4 because they cancel out. All right? One last, let's go back here. Just slow down. Any questions? Is there a part of this that you don't understand? Huh? Okay, hold on. I kind of changed the question because she said, oh, so really it's 2 to 2, so that means it really doesn't change anything. I go, for that case, it wouldn't. Okay? But what if I was converting to oxygen? These are 2 different questions. This will give you liters of oxygen. If you were to do it for liters of water, it'd be 0.350 liters. 2 liters of hydrogen will form 2 liters of water. See that? Okay, so the last few questions in your study guide, in your worksheet, is kind of like this one, where I give you the volume of a gas at certain conditions and ask you to convert to mass. That is a liter, not at STP, to mass. I told you yesterday, you just go in reverse. So yesterday we did train track and then ideal gas law. Today we have to do ideal gas law, then train track. Do they give me the pressure of this gas? Do they give me the volume of the gas? Do they give me the temperature of the gas? Then I can use R to solve for N. So let's do it.
What is R and N? Oh yeah, what about N?
Pressure is volume is R is the ideal gas law constant. We have 2 in our disposal, 0.0821 or 8.31. This one's going to be, and T has to be in Kelvin. I need a calculation there. Moles of hydrogen gas. Now it's like being already 1/3 of the way into the train track. So we need to convert to grams of zinc. So we're going to have to travel from hydrogen land to zinc land. Where do we get those numbers? 1 to 1. And then finally we go to the bank to exchange our moles of zinc for grams of zinc, and the bank will always give us, for every 1 mole, the formula mass. What's that? What is it, Esther?
10.0.
And now I believe I've taught you how to do all of that worksheet.